Well, this proportionality constant is called the resistance and is denoted by the letter R. But why do you think it's known as resistance? Well, as the name suggests, it offers resistance to the flow of charges through the conductor. Very much like friction is resisting the movement of this table right now.
As we saw, when we increase the potential difference, the current produced also increases. So the current I flowing through a metallic wire is directly proportional to the potential difference V across its ends, provided its temperature remains the same. This is known as the Ohm's law.
Ohm's law is to electricity what Newton's laws are to mechanics. Now, the SI unit for resistance is ohm and is denoted by the Greek letter.
So if 1 volt of potential difference is applied across the ends of the conductor and a current of 1 ampere flows through it, then resistance of the conductor would be 1 ohm.
One inference of the Ohm's law is that the current produced is inversely proportional to the resistance of the conductor, which is quite logical, right? I mean, if there are more difficulties in the path, we would find it more difficult to run through it. Similarly, when the resistance of the conductor is more, the charges find it more difficult to move through it, and hence the current produced is less.
So if you double the resistance, current gets half.
We already know that most appliances that are current driven need to be regulated. Like we need different appliances to operate at different levels or different speeds.
Say fan, for example. We sometimes need it to operate at higher speeds and sometimes at lower speed. To do that, we need to operate the current flowing through it. But we know voltage supplied at our homes is 220 volts. So to increase or decrease the current through it, we can change the resistance by just rotating the regulator.
Resistance is usually a very commonly used regulator in most cases. The component with which we can vary the resistance in a circuit is called a rheostat.
Like in our fans, the regulator has a built-in rheostat which changes the resistance every time we move it, thereby controlling the current and so the speed of the fan.
We know the electrons are free to move in a conductor, but they are not completely free. Their movement is restrained by the attraction of the atoms among which they move. So, the motion of electrons through the conductor is retarded by its resistance. And like the routes where there is less traffic are called better routes, similarly, components offering low resistances are good conductors. So, a component of a particular size offering low resistance is a good conductor of electricity, while the same size component offering high resistance is considered a bad conductor of electricity.
For example, all the metals are good conductors and have the resistance of the order of 10 to the power minus 8 ohm. A conductor having appreciable resistance is known as resistor, while components having extremely high resistance are known as insulators. Insulators have resistance of the order of 10 to the power 16 ohm.
Air is a classic example of an insulator. When lightning strikes, it heats up the air in its vicinity to a temperature of about 20,000 degrees, which is almost 3 times the temperature of the sun. Now you have an idea just how much resistance air must offer.